Hi there! I own a Model A Ford. Chances are you do too, and if you do, then you probably notice that in between the engine and the rear wheels there is a little something there which doesn't like to cooperate all that much. Especially if you aren't blessed and live in a world that's completely flat. I certainly don't. There's a bunch of hills around here, and they all seem to get a certain sweet spot. You know, there is steep hills where you just say, well, my car has just got 40 horses, I ain't never going to pull up that hill in third gear. Just stick to second and, slowly make your way up there. No! Most of the hills around here just take that perfect gradient where you think to yourself, if I only was in third gear and had the momentum, I would easily be able to pull up that hill doing 30, 40, maybe even 45 miles an hour. But no, you're stuck in second gear because there was a traffic light down in the bottom, and now you're stuck in that gear and you're trying to rev the motor high enough to get in third, but by the time you found the time to switch into neutral, wait until the engine calms down and then shift into third, you've lost all your speed and you're starting from rock bottom again. So switch down to second and creep up the hill doing 15, 20 miles an hour, keep the engine happy and everybody behind you gets angry and so on and so forth. Well, I decided I was fed up with the whole thing. My transmission is garbage anyway, so it needs a rebuild. And while I'm rebuilding it, why not put a little something in there, eh? We're about to get towards a hill, which is exactly what I'm talking about. And it's made especially nasty because you have to start out doing no faster than 30 kilometers an hour, which is 20 miles an hour. And then at the hill, you're supposed to speed up. So this is 30 kilometers, 20 miles an hour. Already pretty high RPM, right? Now we're supposed to accelerate to 50, which is 30. And I can do that, and it's getting increasingly loud. And now I could climb this in third if I had the momentum, but I have to wait so long in second that now, by the time I can switch into third, I'm at 25 miles an hour, 40 kilometers an hour, and it's just not happy. This hill is okay because it levels out, but we've got a lot of this type of hill around the region that I live in, and well, I'll just show you another one for demo purposes and you'll see what I mean. When you already are doing 30 miles an hour, then it's no problem to keep up that momentum or even build up speed. This hill is about the same steepness, incline as the one we've just climbed, and as you can see on the speedo, hopefully, it's able to keep up that momentum, keep it going, no problem, the torque will get you there. But then there is this one curve, which you just have to take in second, everything else is impossible, and then you're just not getting out of it. I'm going to try for the camera, but obviously this is not what you should do. And there you go, you lost. Alright, so back into second. I'm back to doing 22, 25. But the transmission and the engine screaming at you, screaming for mercy, wanting it all just to end. And of course with the fuel economy skyrocketing or plummeting, whichever you like. Try again. Just about. It's not happy doing that. Absolutely not happy. So what's the big idea? I'm gonna tell you exactly what the big idea is. Here, come take a look. Look at this graph! This is the inner workings of a Model A transmission. Looks complicated, but it really isn't. We've got an input shaft right here coming from the engine, we've got an output shaft right here going to the rear wheels, and then we've got an intermediate shaft which is doing the shifting of the gears. You can see there is a bunch of gears on here, and this one gear is in constant mesh with the input shaft. So it's always turning as long as the input shaft turns, and it is reduced by the ratio between gears here. Now, if we shift this large gear from the space in which it can revolve freely into this gear, then we've got first gear. Shift that one back and put this gear into that gear, then we've got second gear. And if we want third gear, then we just slide that gear right on up onto the input shaft and create one straight line through with completely disregarding the shaft down here. Reverse gear would be by shifting this one over here, but that's not really necessary for what we're doing. The important thing that I want to point out here is that first, second, and reverse, which we don't need, is coupled onto the intermediate shaft, and the intermediate shaft is in constant mesh with the input. So if we just simply change the ratio between input shaft and intermediate shaft, then we can alter first, second, and reverse gear, but we're keeping third gear one-to-one straight through. And that's exactly what I want to do, because I've written me down the ratios for first, second, and third gear, and they are 1-to-1 for high, as we saw straight through, 1.85 to 1 for intermediate, and 3.12 to 1 in low gear. And that means when we're going full throttle basically, or somewhere there along, then we can go 55 in third gear, we can go around about 30 in second, and we can go 18 in first gear. When you take a look here, then you will notice that that gap here is a lot larger than the gap between first and second. And that's what I want to alter. In essence, what we're doing by changing the intermediate shaft ratio is we're increasing first gear up until here. Let's call that first star. And we're increasing second gear to go up here. And now all of a sudden, we've got the same spacing between second and third as we do between first and second. We don't need first gear to be this low, especially not on a coupe. You could easily start the car in second, and with the new first gear we are still below the old second gear, so I'm not worrying about that. And we're bringing second gear up a lot, closer towards third, so that we can go, well, what's that here, maybe 35 miles an hour at top speed in second, and then shift into third and continue on our way without getting into that low spot, powerless lugging that I showed you early on. My first idea of accomplishing this was to machine the old shafts, taking down the old gears from the input shaft and the intermediate shaft, pressing on a new gear onto both, and thus making for a different ratio. However, that would mean we would get a very, very thin wall on here, and since these pieces have to be heat treated and most likely shrunk and welded onto here, that just wouldn't make for a great holding power. So I decided to make both of these out of fresh stock and machine them from scratch. You can see this is the new intermediate shaft with a smaller gear right here. And this is the new input shaft with a larger gear right here, while still retaining the same amount of gearing to get the direct engagement into third gear. You can also see that there is an undercut right here. That's because there will be different amount of teeth right across each other. The original input shaft just has one spline going right through, so they didn't have to bother with that. This is going to be our weak point, right here. You can see changing contours here and here and a rather thin wall thickness. I'm hoping to get by this point by leaving this here with a lot of meat for heat treating and then boring it all out afterwards so we don't get a through hardened portion on here. That would probably make this so brittle it would just snap right off. It's gonna be a gamble. I did some calculations, and the safety factor on here would still be somewhere like 12. So, you know, the numbers say it's correct, but we're going to have to find out the hard way, I'm afraid. Anyways, that's the idea. The gearing itself I won't do myself. I just don't have the means to make a proper gear. I could get close with the shaper, no doubt about it, but I want this to work very well. I want the power transmission from teeth to teeth to be the same, so it would last the longest time, it would be as noiseless as possible, and of course so it just doesn't break apart upon trying to launch it a little harder. The parts have gotten a little dirty. That's because they've spent 5 hours in an oven and then 3 more days cooling back down from it just to get the stresses in here relieved. I do not want to take all the nice finished dimensions and then throw this into an hardening bath and have this turn out all crooked. So this is a way to relieve any internal stresses without distorting it any. Now these are ready to get the teeth cut into them. I've also put my maker's mark into here just so anybody who needs to take this apart knows that this isn't stock. The transmission parts are back. You can see they've put some very, very nice teeth on here. I really couldn't be happier with these results. I mean, they are so smooth, they almost look like they've been ground. You can also see the difference in the gear size here when we put them next to each other. And, well, on here you can also see that now instead of having one continuous gear, you have 2 separate gears and the spline on the end. Now, they are here because I will have to do some preparation work before they can be hardened. You can see that these teeth here are rounded off on the corners, while these aren't yet. There are machines to do that, but I'm just going to do that by hand with a file. so the gears will shift a little bit easier. These teeth here are rounded off too. I won't do that on this one because I have redecided. I'm not going to go with this shaft for a solution. I have had a little bit more thought process going into this, and I've looked at the cross section right where the undercut in the middle is, and the wall thickness in here is not really enough for me. Technically, I'm not weakening it any. The small cross section is present here as well, but here you've got the ribs of the teeth that are going once completely through. On here you haven't. You've got an interrupted contour, and that's where stress is going to rise. So I've done some simulations, and they told me the exact thing I was fearing. The safety factor of this one compared to that one is a little bit less. I don't remember the figures, but if this one was 3.5, then this was 2.7. Along with the thinner gear for first, second and reverse, as you can see, the gear surface is a little reduced. I decided, rather than going this way, we are in fact going to machine this one here off, right up until here, machine a shoulder onto here, and leave a remnant of this gear stuff on here. Then we're going to make the exact counterpart of this with an internal gearing, a little bit like a spline, and have it interference fit on here. Onto that blank we can separately put some teeth before mounting it onto the shaft, and that should give us a lot more strength and stability while retaining that different transmission setting. It's a shame that this beautiful shaft will do no real purpose other than look good. Maybe I can use it as an alignment tool for, clutch installation. That's about all I can think of right now. But to be honest, it's better than risking a premature failure of this, because that would mean taking the whole dang thing apart again, probably some damage to the gearbox housing. So yeah, that's the decision I have made. This one, perfectly fine. This is going to work out the way it is intended. So we can do our radiusing on this one. Drill the oil holes for this one as well. You can see there is one right in the center. And yeah, once this second gear blank is here, we can send that all off to get hardened and move on from there.
Wenn ein kleiner Zufall will, stehen zwei junge Herzen plötzlich still. Heimlich träumen sie zu zweien, Zufall ist das nicht allein, das muss schon ein bisschen Schicksal sein. Man vergisst für lange Zeit Namen, Zukunft und Vergangenheit. Und die ganze Welt steht wie auf einmal still, wenn ein kleiner Zufall will.
Well, about 1,000 years later, one thing is clear: I now want a gear deburring machine. All the teeth are done, and so am I. I'm completely exhausted, because you've got very limited travel here to do your deburring. The file is so upset, it started calling me names. And, well, I'm just glad this is over, and I don't have to do the second shaft now. Now it's ready for hardening, actually. It's a week later, and the single gear blank is finished as well. We've determined the hardness of the gears that were previously used by using a special hardness testing machine. It has a hardened tip which gets forced into the material under a certain load, and the machine basically measures how deep the indentation is. The readings averaged out around 53 Rockwells, so I'm going to ask the heat treatment shop to make these gears about the same. During a brief preliminary assembly, I've noticed that the play between the input and output shaft is too much for my liking. You can see that there is a whole lot of slop here in the bearing fit, and I've measured this pin here, and the diameter is actually, I think, 3/10 smaller than what would be prescribed. So, rather than throw this away or buy an oversized bearing, I've made myself a brass bushing, bronze rather, this has to last, and I've machined an oil groove into here, which lines up with the oil hole in the shaft, and then I've tried my best at hand cutting a groove which goes all the way to the back, hoping that this will improve the oil supply. It's going to be a press fit into the shaft here, and then a very nice play-free fit on this here. Now I've constructed and built this contraption. I know its weak points, and I want to prove all the calculating that the computer has done for me. I want to hook my torque wrench up to this. I know the engine is putting out somewhere around 135, maybe after the rebuild 150 Newton meters. So I'm going to test it by 200, and I'm going to use the torque wrench, put an old socket onto the square, and weld that socket into an old clutch plate, so that I have an adapter for the spline. Well, for you it's only been a quick cut. For me it's been 2 months, but the shafts are back from hardening. And although I'm not going to use this one here, I decided to have it hardened anyways, because now I can test this V1, if we want to call it that, for strength. You see, the numbers say this thing is going to last, but who trusts numbers, right? So now I can slide this second speed gear onto here, put a shaft in between, and then use my homemade adapter on the other end to torque the ever-living crap out of it. There's 200. And there's the torque wrench. The cool stuff always happens when you don't record it. I repeated the test for science reasons, and I was on here with my full weight, so if I calculated half my weight, then now we were at 800 and something Newton meters, and I'm just going to say, well, there's one, but okay, this is really not supposed to be the subject of the video, but I'm kind of curious what went wrong inside here. So let's take it apart and see. Do you see something? I don't know. Really hard to tell what caused the issue here. The input shaft is back from machining. You can see the step here and the final profile which the new gear blank will be pressed onto. Sadly, they couldn't machine the undercut here, so I'm going to go with angle grinder and lathe to do it myself. At work, we measured out the remaining tooth profile on the input shaft. I then dialed all these coordinates into my CAD, made the entire contour 0.03 of a millimeter smaller, and then had this wire eroded into the contour of the gear blank. A little heat should make it expand enough to drive it on, and then it should be a very strong bond.
James Bond.
Man vergisst für lange Zeit Namen, Zukunft und Vergangenheit.
There we are. That was fucking brutal. But it's home. Well, here's one more part of the puzzle. Now it's actually time to put everything back together, see if it fits. Moment of truth. I'm not going to cover removal and installation of the transmission. I did that during my crash episode, so feel free to take a look in there. I'm just going to show you what the transmission looked like before I started work on, and how to disassemble and reassemble the transmission itself. That looks like someone fired a shotgun at it, and the first speed and reverse wheel isn't much better. That causes a very, very annoying howling noise. The next thing that would happen is that these side faces of the teeth from shifting gears poorly would wear down, and eventually the entire gear would be conical, and there would be side forces exerted on here, which would result in gears coming out of mesh, and the gear lever knocking your kneecaps out. And I've just now noticed that we're missing half a teeth down on the intermediate shaft. Right there. That's probably the banging that I've been hearing all this time. So here is the newly hardened, ground, modified shaft. And this is going to engage with this one right here, like so. Now usually you would make 3 bearings. One goes onto the input shaft. Since we've got a bronze gear there, remember this one, we won't need that. And then there is a long and a short one. And the short one, the long one goes on the small gear, and the short one goes on the big gear, because the smaller the gear, the higher the load, right? For the reassembly, I have of course got Les Andrews close by my side. However, before I put the bearing on here, I will of course put the oil slinger on here, and then I'm going to have to cheat a little bit, because for some reason I have miscalculated or mismeasured, and I need a spacer to get the shaft into proper alignment. Shouldn't be a problem, just didn't want to make you unsure. I've put the transmission into reverse and second speed at the same time. Now we're going to have to load test it once again to make sure. Okie dokie, looking good. There we are. Now it was finally time for the first test drive. Now, if I've done my math right, this is just going to work out fine. However, I didn't trust my numbers, so I wanted to do a clutch kick right at the beginning. The clutch did me a favor and served me with the best kick load that I could have ever asked for, because it was stuck to the flywheel, so I basically had to start the car without clutching it. I then did a mini burnout on the driveway, and since I hadn't bolted the floorboards in, I was so jolty with the throttle that just served as good enough a load test for my purposes. That was the first drive I had done after the accident 7 months ago. I was so fueled up with adrenaline that I couldn't really make any scientific notifications on whether the new ratio was actually better than the old. So after cooling down, I finished bolting the car together and made a proper test run. Welcome to the first proper test drive of the new gearbox. We're now approaching a proper hill to see if second speed did anything. And boy, did it do something! We're doing 25 and the engine is not even screaming. That's really, really impressive. Wow! Another 30 kilometers an hour, 20 mile an hour hill. So downshift. Wow! Pardon my excitement, but the engine isn't screaming and I'm doing 20 and I could easily do 25. This is so effortless. Before, 25 miles an hour was nigh on impossible in second gear. It was full throttle and everything was screaming, stop, don't do it. Here's another good hill. To shift faster. I tried shifting it slow, it didn't really want that. So there you go. Getting into third on this hill was always a nuisance before. And now it's just effortless. Another quick shift. Wow! So not only did changing the ratio improve the drivability, it also improved shifting times. Go 30 miles an hour just like that. 32, 35, no issues. And into third. Boom! I could slowly shift into third before. Man, if it wasn't so complicated, but changing this transmission just transformed this car. There's no other way to put it. And so I was happy with my transmission modification, drove around a couple of times, visited a friend, bragged about my mod that I had done and how I would outrun any of his cars anytime soon in any kind of traffic race. On the way home, I sat at a traffic light and I heard a slight clunking noise coming from the transmission. Went away when I put the clutch in. And when I departed from that traffic light, it became very loud immediately. So about a kilometer later, I decided I wasn't going to arrive home in this. Had myself towed and opened up the shift tower to have a look inside. That explains a lot. So from here on out I have basically two ways to go. Number one is go back to stock, no big deal. Number two is going to be stick with my modification and redesign it so there is more meat. I haven't decided on that yet. I haven't got a solution for it yet, so I don't know for the moment. I'm not going to film me taking out the transmission yet another time and the rear axle and all that, that's for sure. But I'll keep you updated what I'm going to do. And about the bare metal fenders, that's a whole different story. Stay tuned. Bye bye. And when I departed from that traffic light, it went very violently. 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 Scheiß die Wand an, ey!